Hi all. There was no video yesterday, so there's another one coming out today. You live on the land. The earth has water, which humans can't survive without, soil for planting. But what about Venus? Right now, Venus is probably the most inhospitable planet for any life. The temperature here is even higher than on Mercury. Although the latter is closer to the Sun, the temperature on Venus is plus 462 degrees Celsius. The dense atmosphere creates a lot of pressure. On the surface of Venus, the pressure is 92 times higher than on the surface of Earth. And the carbon dioxide in the atmosphere turns to liquid under this pressure. The atmosphere is extremely toxic. Clouds of sulfuric acid fly across the sky at tremendous speeds. However, scientists are still very fascinated by Venus because it looks a lot like Earth. Scientists call Venus the Earth's twin sister, because our planets are very similar in size and composition. Indeed, the planets are formed from the so-called protoplanetary disks. This is a collection of matter, dense gas, which orbits a young star. Over time, planets form from it. The matter that formed the basis of our Earth and Venus is plus or minus similar. After all, the areas of gas from which both planets originated were, by cosmic measures, very close to each other. A team of astrophysicists from the University of Geneva modeled the situation at the dawn of the solar system. And they managed to find an answer to why the Earth and Venus followed different paths in their development. Scientists published the results of the study in the scientific journal Nature. The tragedy of Earth's twin sister, scientists applied climate models, which are used to model our planet's climate, to conditions that were more than 4 billion years ago. Back then, Earth and Venus were hot and covered in magma. In order for oceans of liquid water to form, it needed a fairly low temperature for condensation to take place. Clouds of water vapor were formed and it rained. This process takes at least several tens of millions of years. 4 billion years ago, the Sun was 25% weaker than it is now. And it was perfect for the Earth. It was cold enough for the condensation process to sweep across the planet. But this didn't happen on Venus. According to the climate model, all the clouds gathered on the night side of Venus. The clouds, instead of spreading evenly over the surface, gathered where it was cool, and failed to protect the daytime part of Venus from the scorching Sunday. Although Venus is not turned one side toward the Sun, like the Moon toward the Earth, for example, because its rotation is synchronized with the Earth's, it rotates slowly. So it is almost always night on the opposite side. So, over the same millions of years, the clouds have only contributed to the greenhouse effect, keeping heat on the planet. And water could only exist in the form of steam. The Earth could have gone the same way. If the Sun had been as bright as it is now 4 billion years ago, we would have gone the way of Venus. Earth would not have been able to accumulate liquid water. The atmosphere on Earth itself was red hot, with volcanoes raging everywhere. And, as scientists note, the dim young Sun was the key ingredient that actually formed the first oceans on Earth. Where did water disappear from Venus? All right, there was a greenhouse effect on Venus. But where did all the water that was here go? It could have remained at least in the form of steam. There could have been just as much water on Venus as on Earth. But the solar wind gradually swept away all the water. Even now, Venus continues to lose what little oxygen and hydrogen it still has in its atmosphere. Of course, Venus is closer to the Sun than our Earth, and this means that the action of the solar wind is more destructive here. But it's not just this. After all, Mars, for example, is much farther from the Sun, and has lost all of its atmosphere of oxygen and hydrogen. The problem is the weak magnetic field of both Venus and Mars. They can't withstand the solar wind. The Earth has a strong magnetic field, and our planet can take the hit. The weak magnetic field of Venus is influenced by low convection in the mantle and slow rotation. But, in addition to this, there is also quite an earthly factor. Why does the Earth have a strong magnetic field, if by composition we are very similar to Venus? Earth's collision with the planet Theist. The hypothesis of Earth's collision with a large planet answers many questions about the uniqueness of our planet at once. Theia was one of the Mars-sized planets in the solar system. At some point it went out of orbit and collided with the Earth. Such a scenario was quite possible at the dawn of the solar system. You can read more about this hypothesis on the site of the American Institute of Planetology. When the planets collided, they heated up and collided as two liquid spheres, and exchanged matter. The core of Theia merged with the core of the Earth, and our planet's core became denser. And the remnants flew away in the form of the Moon. This explains well the specificity of our nucleus. It turned out to be much more dense, saturated with iron, than that of Venus or Mars. And it gave us that all-important magnetic field. As for the Moon, analysis of its soil has shown that its composition is identical to that of the Earth. But it lacks density. There is no powerful iron core. What if we create an artificial core? But this is my fantasy. In my fantasies, you get likes, you subscribe to the channel, and you get likes. Bye, everybody. Google, Microsoft, Facebook, DeepL. DeepL.TechCrunch.